I'm here to show you how to use the x-Rite color checker video, which is a target of scientifically color balanced chips for use in production and post-production. On the back, we have the white balance target. It's spectrally neutral, which means that it reflects all frequencies of any light that hits it. This makes it ideal for any lighting situation you might encounter. Back on the front, we have the grayscale. At the very bottom, we have glossy black, which represents values from 0 to 10% on the IRE scale. Above that is dark gray for values from 20 to 30%. Above that is light gray for values from 40 to 50%. And at the top is white for values from 90 to 100%. Adjacent to that is a column of squares that gives you a grayscale ramp through the middle section of the tonal scale, with values from 20 to 90% IRE. On the outside edge are the skin tone chips. These are scientifically color balanced from light to dark with some minor undertone variations. On the other edge, we have saturated and desaturated chromatic color chips for use in conjunction with the vector scope in your editing or color grading software. We'll get to these more when we get into post-production. Additionally, there's a Color Checker Passport video, which gives you all the same scientifically color balanced chips, plus a focus chart, all in a handy hard shell case that fits right in your pocket or camera bag, so you never have a good excuse to not have one with you. Inside of DaVinci Resolve, our first step will be to use the color match feature. This allows us to place a specially designed grid over the front side of our target, and it allows Resolve to basically automate this entire process for us. The first step is to set your interface layout to color, and choose the color match palette from the left-hand side of the palette panel. This gives you access to the color grading tools we will need. Next, find a frame in your video clip with the front side of the target. Be sure to find a frame where the glossy black is not reflecting any lights. This ensures that the glossy black is true black. Having any reflections can skew your results and can make these adjustments much more difficult. Then, under the Color Match tool, choose the chart we are using. In this case, it's the x-Rite Color Checker video. Under the on-screen control menu pop-up, choose the Color Chart Qualifier. You'll notice a grid-like overlay that appears over your video. You'll also notice that it has a layout that is reminiscent of the x-Rite Color Checker video target. Resize the color chart overlay so that each of the sampling boxes line up with their respective chips on your target. Back under the Color Match tool, choose the appropriate source gamma for your media and press Match. Utilizing the information collected by the sampling boxes in the color chart overlay, Resolve creates a grade for your clip quickly and easily. If you find yourself wanting to have more control over your grade, or prefer to grade manually, then fear not. Let's reset everything and start over. To do all this manually, the first thing you want to do is make sure your whites are actually white. First, we need to find a frame that has the white balance side of the target. To isolate the white balance target itself, choose the Window palette from the center palette panel, then turn on the polygon controls, and adjust the power window so that it fully encompasses the target. This allows us to use the RGB parade and very quickly and easily verify that white is white and make any adjustments necessary. From the left-hand palette panel, choose the color wheels and switch to page 2. Here you can access the temperature and tint controls. Adjusting the temperature and tint controls will affect all 3 color channels in the RGB parade. All you have to do is make these usually minor adjustments until the red, green, and blue channels are all in line with each other. Once those adjustments have been made, we can be sure that the white shown on the white balance side of the target is actually white. The next step is to turn off the power window and find a frame with the front of the target. Just as before, be sure to find a frame where the glossy black is not reflecting any lights. Turn on your waveform monitor and adjust the power window so that it isolates the center portion of the target, or the grayscale. Under the color wheels controls, adjust the lift so that the values in the waveform scope rest right at 0. Adjust the gamma, and then adjust the gain. Normally, you would push the gain all the way up to 1 volt, but in this case, we have a problem to consider. Turn off the power window and keep an eye on the bright highlights coming in from the side. With our power window on, pushing our gain to 1 volt would cause this entire area to clip, which is something we don't want to happen. When you have a situation like this, it's best to turn off the power window and push the gain as high as it can go without causing anything to clip. Clipping the whites will cause you to lose detail in those highlights, and we want to push this as far as we can without losing those details. Once you've got that dialed in, we're going to move to the vector scope. Adjusting our power window again, we're going to move it over to the chromatic color chips. Be sure to set your vector scope to show 2x zoom. Normally, these squares represent 100% saturation, but by turning on the show 2x zoom setting, we are essentially telling Resolve to treat these boxes as if they are 50% saturation, which is the same amount of saturation in the chromatic color chips found on our target. We end up with this spider web in the center of the vector scope. Each of these arms represents a different color chip on our target, and these color chips correspond to the color targets inside the vector scope. Now choose the Curves palette from the center palette panel and switch over to the Hue versus Saturation curve. First, click all 6 of these color buttons at the bottom: red, yellow, green, cyan, blue, and magenta. Each of these buttons places a point on the Hue versus Saturation curve at precisely the right place to represent the 6 colors in the chromatic color chips portion of our target, which is also the same colors represented by the boxes in our vector scope. The Hue versus Saturation curve allows us to target a specific color, in this case the colors that are represented by the chromatic color chips on our target, and it allows us to adjust the saturation of each color independently of the other colors, rather than doing a global adjustment. Grabbing each of these points, pull them up so that the point at the end of each arm sits inside the boxes in the vector scope. You have to use some best judgment here, because different cameras can capture different colors in slightly varying degrees of hue and saturation, so the colors you have to adjust at this point and the degree to which you have to adjust them can vary depending on the camera your media was shot on. With any of these arms, pushing them too far can cause them, and the arms adjacent to them, to start to break up or splinter. They generally need to sit at about 50%, which is right inside these boxes since we turned on the show 2x zoom setting. Without that setting, they would need to be about halfway to these boxes, but only push the saturation as far as is safe. Be sure to always preserve the integrity of the image. This should be paramount at all times. Once those are all done, we can move to the Hue versus Hue curve. These controls allow us to take these same isolated colors and make adjustments to the color itself, as opposed to the saturation of those colors. We can see that some of our arms aren't quite lined up properly. The Hue versus Hue curve allows us to fix this. Start off by pressing these same color buttons at the bottom to add the same points to this curve that we made in the Hue versus Saturation curve. You can see that by making even slight adjustments to the yellow point, we can cause wild adjustments to the yellow arm. So the changes we make in this curve are almost always going to be minor, so keep that in mind. Pull the green point down so the green arm in the vector scope is lined up properly. Continue through the points until all the arms of the vector scope spiderweb are aligned properly and either sitting inside or at least pointing to their respective color targets. Well, that brings us to the end. We can now turn off our power window and see that our image has been properly graded, and we can now copy the grade and paste it onto all the other shots in this scene, and then move on to all our secondary color grading. It is a good idea to give each shot a once-over and verify that each is in good order. There's nothing wrong with double-checking your work. Thanks for joining us.